To the series of DSA, and today's topic is insertion sort. And today we will be going to discuss about what is this sorting technique and what we are going to do in this. Okay, so I have taken an array, right? So how insertion sort works? The main funda of insertion sort is, like, suppose I am on this index. So let us take this. Okay, if I am on this index, then this must be sorted, and I have to insert to the correct place in this. Means if it 4 is here, I have to insert it here and shift all these elements here. Okay, means like the total will be 4, 34, 78, and 90. This means till the current element I have to sort. This is the main funda of insertion sort, and I have to repeat for all the array and I have to iterate. Okay, so how are you going to do is, let's have a look at it. Okay, like suppose I am on 34. I will not take a 34. I will start my loop from 1 index till the end. Iteration I will start from index 1. So when I start my iteration, I will check whether this is lesser than this. Yeah, I can see that this is lesser than this. So there is no need for insertion. Then I move, then my cursor will go to this index. As soon as it goes to this index, then I will check for whole array and I will compare from the last index that is this lesser than this. It will say no. So it means it is at the correct position. So I've iterated till here. Then when it will go to this index, what it will do, it will check. How it will check it, that is this lesser than this? Yes. So it will swap its position. So here instead of 4, we will get 90, and we will take a temporary element and store 4 in it. Okay. If I will store, then it again compare to this pointer. It will compare that 4 is lesser than, yes. Then it will again swap with the previous position. Then again it will check whether 34 is lesser than 4. Then it will again, and here we will get 78, and here we will get 34, and the last position which is left, we will fill in 4 there. Okay, so this is till the sorted here till now. Let me write it in the sum. Let me type out only. Here will be 4, 34, 78, 90. You have to start from 56, 31, and 3. Okay. So now what will happen? We will take 56 and store it in a temporary array. Sorry, temporary variable. And we will store it somewhere. Here, I have stored 56 here. Then I will compare whether 90 is lesser than 56. No. So it will swap here with the current position of 56. It has been swapped. So now this becomes 90. Right? When this becomes 90, we will check, our cursor will go to this index. Okay, and it will check whether 56 is lesser than, yes, 56 is lesser than and 78 is greater. So it will again move to the last index and it will become 78. Then again our pointer now will decrement again and go till here, and we will see, yeah, that 34 is lesser than 56. So 56. So we will take this position. We will check this position. Yeah, this position is correct. And then when we will get this position, we will put 56 here. So I hope this is clear now how it is going on. Let's move to PPT. As you can see, we traverse the array and sort all the elements before the current element. As you see, this if this is our index, then all these are sorted. We place the current index element to the correct position. It's kind of inserting at correct place. Like we have inserted 56 over here. And we will repeat by iterating over the array. Now let's move to visual representation of, and I will be using tool visual. Okay, so now let's start. Okay, as you can see now, we have taken, if you are not getting, let me tell you again, this how it is going on. Like suppose our current index is at this index, right? As you have seen earlier also, when I was on this, I was checking. If I was on this, I was checking which position will best fit. Yeah. So okay, we in this we have taken 56. Yeah. If I am on 56, then I'm checking whether this, then I will move here. If this is lesser than, then I will move here. Then I will put at this value. You can see here the same thing is happening. Let me slow down it little bit. Now you can see it will check. Yeah, it is not, so it will place. Now our index has 27. We will take it as a temporary variable, check. It will not insert here, then again check, then again we will check with 38, it will not, then it will shift, then 36 again it will shift, and then we will see 26, then it will place at the current index of the pointer. Again we will see 2, again check. Like you can see, we are inserting. So that's the name from which insertion sort has come down. So I hope this is clear to you. I can fast the pace. If you are still not clear, you can slow down the YouTube video only, or you can check out this website. So as you, I think you have all been cleared how this is going on. Yeah. So this is the sorted array. Now let's move to our, okay, now let's code. How we are going to code? Let's step by step. Now let's see how I am going to approach to the solution is the main important thing before you are learning any algorithm or data structures. See, I am iterating over whole array once, right? Let me not use that syntax. Okay. Okay. So this is I'm going to iterate whole index from the starting only, right? And then each time what I am doing, I am looking back. How I am looking back for int I j equals to I minus 1, I skip greater than 0 and I plus. As you all have seen that I started initially with index not 0, I started from here, as you all remember. So this mistake I have committed here, you don't commit it. And one more thing to note, that I had taken this variable differently. You also take a temp variable ai. So So now we are checking from whether this previous one, this index is lesser than this, means the next index is lesser than previous or not. I will check if aj is greater than aj plus 1. Okay. If this is correct, what will it mean? It will mean that 90 is greater than 56. Yeah. So what will happen? We will swap it. We will not swap. We will make the index j plus 1 as aj. Right. Okay, guys. Due to some problem, my diagram got disconnected. I have again mentioned the array. I don't remember the previous one, so I've just taken this array, and yeah, we were on that. We have to traverse the whole array, right? And we have to take a temporary variable which will store the value of present I, which will store the value of our present time, right? And we will take an index which will take to the backward, right? As I told you. So what we will do, we will make a for loop. There are two ways to do this. We can make a while loop and we can write the conditions in while loop that while j is greater than or equal to 0 and our aj is greater than temp. So in that what we will do, we will again and again put the value by comparing as if there is automatic comparing now. So we will take aj index, okay, our aj plus 1 index equals to aj. What we are doing, we are taking this index to this side, as you can see aj plus 1, okay, and then we will decrement j because we have to move backwards also, okay. Then when we will do this, we will make our last element as a temp. And how we are doing this, how we are getting to know that j plus 1, like suppose if I am on this index, right, what we will do, let me erase this all. If I am on this index, what I will do, I will see 90, and we will loop it till this is, it is greater than it is greater than 0 and it is also greater than 56, right? So we will swap this, not swap, we will put this element here. And when again we will put, because 56, as you all know, is lesser than this. But now when we will go to this now, we will see that it is lesser than. So it will take to this index, means the next index of the pointer. This is the pointer, we have to put 56 here. So this is how we are getting the location of this. So now I think this is done. We will print the array and let's see our result, what we are getting, and is it correct or not. Yeah, you can see now this is the expected answer. As if you arrange it in the ascending order, you will get 5, 6, 12, 13, 1, 12, 13, 1, 1, 1. Okay, now you can see this is how we are inserted. And let's move to a paper. As you all can see, we have coded. Now let's talk about time complexity analysis. As you have seen here that we are, just a minute. Now I have taken it differently so that I'm able to tell you the time complexity analysis correctly. right? If I take this, this is repeating n times this statement, this for loop, right? And this is again a kind of for loop, and it will increment, sorry, it will move n minus I. Okay, it will do the n minus I time for loop. So if we see inside this statement fully will operate n into n minus I times. Okay, oh no, this is hard. Okay, n minus I times, as you can see, and this will become n square minus ni. And you all know that when we consider big O of n, sorry, big O of complexity, we take the highest polynomial degree. And so our time complexity becomes big O of n square. Okay, so this is the worst case analysis, and worst case analysis is when the whole array is in the descending order, and which was the case we have taken in our question or the program which we have made. And when it will be best case, what will happen? In the worst case, what will happen? We will not have to go in this while loop because our earlier array will be sorted. So if we don't go here, what we will see, we will left with this. Okay, let me highlight with a different pen. We will be left with only this statement, and this will not be considered. So highest will be go of n in case of in case of our best case, and this is our worst case analysis. Okay, so this is all about our time complexity, and I hope you have now been clear the difference between all the why it is the best cases we go of n. And space complexity, as you have seen, we have not taken additional space. This array will come within the question only. We have not taken any additional space, so our space complexity will be big O of 1. And this is all about the insertion sort, and I hope you all are clear with all the things about insertion sort. And if any kind of doubt or anything, please comment down below, and the source code and everything will be available in the description. Please check the description for any other PPT or any other link that is required which I have used in this video. Thank you.